Welcome to our video presentation. In the context of the global push for zero carbon technologies, rare earth elements or REEs have become indispensable for electric vehicles and wind turbines. The state of Meghalaya in India, home to the Sung Valley carbonatite, offers an opportunity to diversify REE sourcing, but this venture entails economic promise, socio-political intricacies, and environmental challenges. This proposal seeks to provide an impartial evaluation for all stakeholders addressing gangue mineral utility, environmental and community impacts, carbon footprint, and climate change mitigation in mining, with the goal of facilitating a balanced and sustainable approach to mining REEs in Meghalaya.
The first goal we are talking about is suggested industrial uses for gangue minerals. The gangue minerals present in the carbonatite ore of the Sung Valley are calcite, which is important for cement production and neutralizing acids, dolomite, which is essential in steel making and agriculture, apatite, which is crucial for phosphate based fertilizer production, and magnetite, which is a key iron ore source for steel, aids in mining separation, and supports water treatment for heavy metal removal. Even with important mineral industries like limestone and cement, iron and steel, the northeast region of India is facing industrial underdevelopment due to issues with connectivity and infrastructure. The Sung Valley operation offers new resources for industrial development, but what's needed the most is improved connectivity through road and highway construction, which is crucial for the region's growth. Additionally, available of raw materials like calcite and dolomite, essential for cement production, can help reduce the overall development costs. To improve the efficiency in mining in the Sung Valley, mineral reuse is key. Magnetite plays a dual role by separating essential minerals from the waste and filtering wastewater to remove metallic impurities. Considering that the East Indian sister states rely heavily on agriculture, it is important to explore unprocessed geological resources to enrich soil health and fertility. Sedimentary limestones like calcite and dolomite can counter soil acidification, raise the pH levels, and reduce harmful metals, all of which indirectly benefit plant growth. Apatite and dolomite, rock fertilizers, can also help replenish the soil and magnesium in the soil. So, it is clear that there is potential for sustainable growth and development in this region.
I would like to address the impacts of mining on our environment and communities and the strategies we can employ to mitigate these effects. Firstly, let's delve into the environmental and wildlife impacts. Mining poses a significant threat to our ecosystem, driving wildlife to the brink of extinction through habitat degradation, hunting, and pollution. The spread of heavy metals in land, air, and water affects biodiversity with long lasting consequences. Water plays a pivotal role in mining operations and its contamination poses a substantial risk. Wastewater from extraction, processing, and waste disposal can contaminate adjacent water sources, affecting freshwater resources. This in turn impacts hydroelectric power sources. Large scale mining also has profound impacts on local communities. Displacement leads to hostility, violence, and disruption to traditional ways of life. This can be a challenge. To address these challenges, a comprehensive mitigation approach is paramount. Stringent environmental regulations, prioritizing health and safety, effective waste management, and involving a local community in decision making are imperative. Preserving culture, promoting sustainable mining practices, and diversifying energy sources contribute to responsible mining. Furthermore, establishing a community trust fund, supporting local workforce employability, and promoting small business are crucial steps towards community well-being. Public forums and engagement in decision making ensure equitable benefit sharing and raises awareness about mining impacts and cultural preservation. So, by embracing these strategies and working collaboratively, we can strike a balance between economic development, environmental conservation, and community well being.
Meghalaya has a potential of 3000 megavolt of hydroelectric power, out of which only 11.8% is currently being utilized. The industrial demand of electricity in the state is 41.5% of total electricity produced. To move towards renewable energy, the major problem is posed by hilly terrain. A great example is demonstrated by Antofagasta, Chile, where they outlined a five pillar decarbonization strategy encompassing climate resilience, GHG emission reduction, efficient resource use, environmental management, and stakeholder integration. Use of renewable energy can be integrated into off-grid mining easily by use of hydroelectric, solar, or wind energy. For on-grid mining, the industry can adapt battery-powered or biodiesel-fueled trucks and exploration of hydrogen-powered haulage solutions as practice. New technologies can be implemented to decarbonize mining operations.
I shall be covering topics on the integration of climate change mitigation strategies, which will include mineral carbonation, in situ and ex situ mineralization, and the industrial proposal, which is the 12-step plan. Mineral carbonation is a process that captures carbon dioxide using alkaline compounds such as magnesium and calcium oxides, which are found in natural silicate rocks. This includes minerals such as serpentine and olivine. The reaction between these compounds and the dissolved carbon dioxide results in the formation of calcium and magnesium carbonates. The natural mineral carbonation process, which is known as rock weathering, occurs over a long geological time frame. Ultramafic rock formations, such as those in the Sung Valley, are excellent sources for mineral carbonation due to their high carbonation potential. Tailings, which are leftover materials from mining, particularly in rare earth element extraction, can be reprocessed to extract mineral carbonates, making them a convenient and regularly produced resource. There are two types of mineralization technologies: in situ carbonation and ex situ carbonation. In situ carbonation involves deliberate addition of carbon dioxide to geologic formations, creating carbonates without the need for long term monitoring. This technique is categorized as carbon capture and storage, or CCS. Ex situ carbonation, on the other hand, is categorized as a carbon capture and utilization, or CCU technology, as the resulting byproducts can be used for building materials and valuable chemicals. The exothermic nature of the carbonation process makes it potentially profitable. The heat released from the reactions can be used for energy production, and the resulting solid products, primarily composed of free silica and magnesite, can be can be used for various applications such as soil amendments, mine reclamation, and even as fire retardants. The 12-step plan. Step 1 involves REE mineral mining waste stream formation. Step 2 is the collection of waste minerals. Step 3 is the crushing and grinding of the minerals to particle size for processing. Step 4 is the separation of impurities. Step 5 is the mineral carbonation process, which is the reaction with carbon dioxide to form the carbonate minerals. Step 6 is the precipitation of the carbonate minerals. Step 7 involves the storage of these carbonate minerals. Step 8 is the utilization of the carbon dioxide. Step 9 is the utilization of the end products. Step 10 is the potential implications and the sale of REE carbonates. Step 11 is the waste management. Step 12 is the environmental impact assessment.
Mining of REs in Meghalaya's Sung Valley require economic balance, community well-being, and environmental conservation.
Utilizing renewable energy sources and mineral carbonation can reduce carbon footprint.
According to our proposal, implementing in situ and ex situ technologies at the Sung Valley plant can help enhance waste utilization and profitability.
Engaging local communities through training and trust funds is essential for mitigating adverse effects and ensuring a comprehensive, balanced approach.